All right, guys. What we're doing today is starting chapter 3. So you do need a note sheet.
That's what they did.
Need something to write with. Now, everything we're doing in chapter 3 is... All right.
I'm sorry, Mr.
Hold on.
Sorry about that. Jaden, you're just too slow.
How did that video go? Carl didn't.
Bro, watch that.
No. He's dead.
Oh!
One guy just like, Elmo's so cute. I can't. Oh my pen. Hold on.
Do not think at the same time. I'm not.
I said what I want. If he's not dead by that, I don't think I'm going to die.
You were on your phone the entire time and you looked kind of awkward, so I was like,
Keep an eye on.
All right. So, chapter 3. We're starting chapter 3 today. Now, chapter 3 is going to revolve around quadratic functions. So our ax squared plus bx plus c. Now, the last chapter also was talking about quadratics, but all the ones that we're going to be mainly focused on this chapter are going to come in standard form. Now, we can change it to factored form, where we'll have two sets of parentheses with things inside of them, but we're not going to have it, or we're not going to be looking for the vertex, focus, directrix, or axis of symmetry. And before we start this first chapter, this first section, which is going to be over factoring quadratics, I want to look at distributive property first. As y'all have done this before, when we distribute two binomials, multiply two binomials by each other, we multiply through. So the first thing we would do is 4x times x, which would be 4x squared. Then we would do 4x times negative 3. 4 times negative 3 is negative 12, and we do still have the x. Our step after that is to multiply by the negative 5. We would do negative 5 times x, which is negative 5x. And lastly, negative 5 times negative 3 is plus 15. Now, before we can say we're finished distributing this, we do have to combine like terms. Our only like terms for this here are the negative 12x and negative 5x. And negative 12x minus 5x is negative 17x. And we get to this here, 4x squared minus 17x plus 15. So we distributed through to get this here. Now when we factor, we're going to start out with this quadratic and get it back into factored form, our sets of parentheses being multiplied together. And really that's the goal this here. We started out with this to kind of see how this works, but we're going to go from this form, get to that form, started with this here. We're going to go on and move on to this here. Now factoring ax squared plus bx plus c. Previously, you have factored polynomials of this form with a was 1. But again, it's been a few years. You guys did this in Algebra 1. This is normally last chapter, one of the last chapters y'all covered. But we're going to look at it again, and we're going to have a be different than 1. Now, whenever we factor, doing this here, there are a few steps. And one step that is kind of common amongst any way that we factor quadratics is to first factor out a greatest common factor. We need to find the greatest common factor and factor it out. And when we find the greatest common factor, we're trying to find what number or term can be pulled out or divided out of each of the terms in the expression. So if we look at 5x squared plus 15x plus 10, what would the greatest common factor be? What is the biggest number that divides into all three terms? 5. Greatest common factor is 5. Greatest common factor is 5. And we're looking for the term that will go into every single term, because if we divide 5x squared by 5, we're left with x squared. If we divide 15x by 5, still be plus 15 divided by 5 is 3. We didn't do anything to the x, so we have 3x. Plus 10 divided by 5 is 2. Because using this greatest common factor, it's going to make it, 1, easier to factor, and 2, reduce the numbers or values we're having to work with. And we put it out front, we factored it out. Because if we multiplied it back through, we would get back with what we started. Because when we get it in final, in its fully factored form, if we take that and multiply it all back together, we should get back where we started. And the first thing to do in factoring is to find the greatest common factor and factor it out. Now the second step is to write 2 sets of parentheses. With 3 spaces. 2 sets of parentheses with 3 spaces. So we will still have the greatest common factor. It will be included in our final answer. And then we have our 2 sets of parentheses with 3 spaces. The 3 spaces give us room to write each of our terms. And we get this set up here. Questions on any of this so far? Now, there are different ways to factor. There's different methods to go about factoring. The one that I like the best is one starting out with our 2 sets of parentheses. And the next step, step 3, is to find the sign. Find the signs that go in each of our sets of parentheses. And the way we do this is based off the third term. If the third term is positive, then the signs are the same, and match the sign of the middle term. For our signs, if the third term is positive, then the signs are the same, and match the sign of the middle term. We'll get the other part to it. If the third term is negative, then the signs are opposite. If the third term is negative, the signs are opposite. There's only two other steps after this. So, let's look at this here. What is the sign of the third term? Positive. If the sign of the third term is positive, then the signs are the same and they match the sign of the middle term. So since the third term is positive, the signs that go in these two parentheses are going to be the same, and they're going to be the same as the middle term, in which case it is plus. So we would have plus and plus. Because there are different methods to this. One of them is the cross method, and it really revolves around the factors of the first and third term, and we have to look at the signs of it as well to get there. And this, especially with the third term being positive, to get this third term, we'll look back at this here. Well, the third term was our plus 15. Well, where did we get the plus 15 from? We got it from these two with the sign being multiplied together, yes? Well, a negative times a negative is a positive. The only other way we can get a positive term is if both of those terms were positive, because a positive times a positive is a positive. A negative times a negative is a positive, yes? And in this case, the middle term came from this here. Well, if they're both the same, both of those middle terms were negative, we add them together, we still get a negative. If both of the middle terms had been positive, that would mean both of these were positive. So it's kind of telling us what it's going to be. So here, since the middle term is positive and the third term is positive, they have to be the same, and they're both going to be positive. If it had been minus in the middle, both of the signs would be negative. Step number 4. Find the factors of the first and third terms and plug them in. And let's go on and put step number 5, which is check. Find the factors of the first and third term and then plug them in. And our last and final step is to check. So if we look at this here, the first term is x squared. So what are the factors of x squared? What two things multiply together to give us x squared? X and x. Are there any other factors for x squared? No. 1 and x squared and 1 don't work for this here. X and x are only factors. And if there are only one set of factors, We just plug them in. And it's really going to work out with the variable x squared if it's in the first position or in the third position, because that's the only two spots where x squared is going to show up. We can just plug it in as x and x. If it was w squared, we'd plug it in as w and w. There's only one set of factors for it, so we can just plug those in. Then really the other piece for it would be looking at the term in front of it. Well, the term in front of it is 1. Factors of 1 really don't have an impact on it because it's only 1 and 1. We don't have a lot to it. Third term, factors of 2. What are the factors of 2? Well, 1 times 2. Are there any other factors of 2? No. So we can plug it in. Any questions on how we got through steps 1 through 4? We're ready for step number 5. Yes? Step number 5 is to check. And the main way we check is by multiplying this back out. Now, there's 2 multiplications that I don't think are highly necessary. And I'm going to do them in a different color. Because if we did this out the mathematical way, the first thing we would do is x times x, which is x squared. The next one we would do is x times 2, which would be a positive 2x or plus 2x. The next one we could do is 1 times x, which is plus x. And lastly, we do 1 times 2, which is a positive 2 plus 2. Now we need to combine our like terms. Well, x squared stays the same. 2x plus x is plus 3x plus 2. Is this the same as what we had before we factored? Yes. So what that's telling us is that this here is the final answer. Our 2x plus x would indeed give us 3x. Questions on any of this here so far? Now I did write our x times x and our 1 times 2 in yellow for a certain reason. Because our x times x, where did we get the x and x from? Well, they're the factors of x squared, yes? So if they're the factors of x squared, they will always multiply back together to be x squared. Yes, that's where we got it from. Well, where did we get 1 and 2 from? The factors of 2. So those 2 should always multiply back together to give us 2. Does that make sense? That the factors, when we multiply these 2 together, will always get us back here. Because how do we get them? Well, they were the factors of that term. So they should go back to where they were. The same thing is true with 1 and 2. They're the factors of 2. So we don't necessarily have to do the entire multiplication out. But the main one you have to focus on is the middle term. That's the one that's key. Well, it'll make even more sense here. Now, luckily, I'm not going to rewrite out all the steps again. I wrote them out so that we have them once, that y'all have them down, but we will still follow those same steps, especially with these quadratics. So the first thing we need to look for is a greatest common factor. Is there a greatest common factor between 4x squared, 32x, and 60? Four, because 4 is a common factor of 4x squared. 4 is also a common factor of 32, and 4 common factor of 60. 4 will go into all 3 terms. And to factor it out, really what we're doing is dividing each term by 4. And 4x squared divided by 4 is just x squared. 32x divided by 4, 32 divided by 4 is 8x, plus 60 divided by 4 is 15. So when we divide each term by 4, we get x squared plus 8x plus 15. We do need the 4 out front because it is still part of it. It's still part of the factorization. But we get this here. Any questions on how we got to this point here? So we can move on to step number 2. Our 2 sets of parentheses with 3 spaces. So that takes care of step 2. Step number 3, to find the signs. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So the third term is indeed positive, yes? So the signs are the same and match the sign of the middle term, which is also positive, so we have plus and plus. Questions on this here? So that takes care of steps 1, 2, and 3. Step number 4, find the factors of the first and third term. Well, first term's x squared, yes? What are the only factors of x squared? X and x, yes? If there's only one set of factors, there's only one arrangement of it. Go on and plug them in. So even if we still had, say, 2x squared, well, x squared is still just x and x. We can put it in and then worry about the 2 after that. Third term is 15. 5 and 3. There's one other set of factors. 15 and 1, or 1 and 15, yes. When listing out the factors, I would always start with 1 and whatever the number is, and then go from there. 2 doesn't work. 2 is not a factor of 15. 3 is. 4 is not. And the factor after 4 is 5. Well, we already have it listed as 3 and 5. We don't need 5 and 3. Question on how we found the factors of 15. Now we need to pick which one we want to use. Do we want to use 1 and 15 or 3 and 5? 1 and 15. We'll put the 1 first, 15 second. And at this point, especially when we're going through steps 1 through 4, and especially step number 4, we need to just plug them in because we will always check them. Now, the ones that are not as important to check are these 2 here, because x times x is still x squared, yes? 1 times 15 is still 15. Those are always going to be the same no matter what the setup is. But when we check this middle term, x times 15 is 15x. 1 times x is plus x. And 15x plus x is 16x, positive 16x. Is that the middle term we wanted? No. Correct sign, they're both positive, but we want 8x, and this setup gave us 16x. So we need to change it. So one thing we could do is I could switch the 15 and 1, but has that actually changed anything? No. Instead of having 15x plus x, we would have x plus 15x, which would still give us 16x. So instead of 15 and 1, what could we do? 3 and 5. And again, I'm just going to put one as 3, the other as 5. We're just going to pick a set and try it and check it. Now looking at this here, we did change the 3 and 5. First term, x times x, is that still x squared? Well, yes. The last set, 3 times 5, is that still 15? Yeah. Because we took the factors of the first term and the third term, that multiplication should still give us our x squared and 15. That's not changing. But let's look at the middle term. X times 5 is now 5x. 3 times x is plus 3x. And 5x plus 3x is 8x. Is that the middle term we wanted? Yes. So these here are our factors. Now I will say it is not wrong or incorrect to do the full multiplication, to do x times x and get x squared, do x times 5x. and get plus 5x. Then do 3 times x, get plus 3x, and then 3 times 5 to get plus 15. Simplify. That is not wrong. The reason I'm not doing it is it's an extra unnecessary step. We don't need it. Because we know that when we factored x squared, x and x, that's where we got it. It's going to multiply back together to give us x squared. The 3 and 5, we got it from the factors of 15. They're going to multiply back together to give us 15. The one that we're concerned about, the one that actually changes when we multiply them together, is the middle term. That's the one that changes. That's the one that we're really checking. Does that make sense? Why check more than we need to? We're starting to get the handle on these. Now, I will say one thing with factoring. The more of these that you do, the better you're going to get at them. There are tips and tricks that do work, and once you start seeing them and noticing the pattern, you're going to get quicker at doing these. Now, when we look at this next one here, greatest common factor. Is there a number or variable that will divide into all 3 terms that we can take out of all 3 terms? Because 2 will go into 4, yes? Will 2 go into 13? No. Unfortunately, 13 and 3 are both prime, so they're as simplified as it gets. So not every single one will have a greatest common factor, but if they do, it makes them easier to work with. It makes all the numbers smaller. So there's no greatest common factor, and luckily for this section, all of them will be factorable. So we'll have our 2 sets of parentheses with 3 spaces. Our next piece is to find the sign. And we look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. Well, what's the sign of our third term? Positive. So they're going to be the same and match the sign of the middle term, which is positive. So they're both going to be positive. So that takes us through steps 1 through 3. Step number 4, find the factors of the first and third term. Well, our first term is what? 4x squared, yes? What are the only factors of x squared? X and x. There's only one way we can have that set up. If there's only one set of factors, might as well just plug them in. There's only one way we can have it written. Factors of 4 are what? Well, 2 times any other factors. 4 and 1. Yeah. So we have 2 sets of factors for this here, yes? Now the question is, which one would we actually use? 2 and 2. Now at this point here, we just need to pick one. Because when we start getting the factors, we just need to pick one. And this is also kind of leads into what I said earlier. The more of these that you do, you'll start seeing the patterns of what is going to be a more likely choice between 1 and 4 or 2 and 2. But we just got to pick one. And that's why step 5 is so important, the check step, because this lets us be able to pick one of them and not really have to focus too hard on it trying to figure it out. The check step will tell us either A, yes, this is correct, or B, we need to rearrange it. We need to try a different setup. Now we need the factors of 3. Well, we said 3 is prime, yes? So it only has one set of factors, which is 1 and 3. And I'm just going to plug them in. I could have put the 3 first, right? Second, it doesn't really matter. I just need to put them down. Because no matter how we set this up to begin with, we are always going to check it. And again, there's nothing wrong going with the full process of checking this. Because I could do 2x times 2x. Well, what is 2x times 2x? Well, yeah, where did we get 2x and 2x? We got it from 4x squared. There's nothing wrong with doing that. That is a proper step. I just don't see the point in doing the extra step if we don't have to actually do the extra step. The one that I do find important is our 2x times 3. 2x times 3 is 6x. 1 times 2x is plus 2x. We could have written plus 6x. Without a sign in front of it, it's understood to be positive. We do put a plus in front of the 2x because it is positive. We're adding these together. And well, the last one, 1 times 3 is still 3. But we do combine our like terms here. 6x plus 2x is?
Leo 10, you're needed in Mrs. Kendall's room. The Leo 10, you're needed in Mrs. Kendall's room.
8x, positive 8x. Is that the middle term we wanted? No, we wanted it to be what? 13x. Okay, we need to change something. Well, we could switch the 1 and 3. Yes? It'd be the same because we're doing 2x times 1 and then 3 times 2x. That is exactly what we had before, yes? So that really didn't change anything. So I can go and put that back. So what we can change instead is what? The 2 and 2. So we're going to do 1 and 4. Do we want the 1 in the first set of parentheses or second? Or do we want to put the 4? Doesn't matter. I'll put it over here. Because we need to check this still. Well, x times 4x is still 4x squared. 1 times 3 is still 3. But x times 3 is positive 3x. 1 times 4x is positive 4x. And 3x plus 4x is 7x. Is that the middle term we wanted? No? Well, would switching the 1 and 3 do something this time? X times 1 is 1x. Okay, yeah, this does have a bit of a different impact because 1x and 4x would give us a little bit different product. I switched the 1 and 3. Because 2x and 2x didn't give us a different result because 2x and 2x, they are the same thing. We really didn't change anything. Here, switching the 1 and 3 now gives us this x times 1. But it also tells us 3 times 4x, which is plus 12x. And x plus 12x is that the middle term we wanted? Now, at the start, it's going to seem that way, and it's going to feel that way. But again, the more of these that you do, the better you get a feel for them, the less of these that you're going to need to check. Because you're going to start getting a handle and seeing how the numbers work together, how they work to give us that middle term. And it's going to start giving you a little bit better intuitions of which one do we want to try first, which ones do we want to leave to the end. Does that make sense? And unfortunately, this is one of the few things in Algebra 2 that's really more of a guess and check. We're going to try it, keep trying, keep trying. But one of the nice things with these is if you get it right on the first time, you're done. You got it right. We can move on. Now the next one we're looking at is this one here, 3x squared minus 7x plus 2. Is there a greatest common factor? No, there's not a number that will go into all three, and also 3, 7, and 2 are all prime. So we can move on to the second step, our 2 sets of parentheses with 3 spaces. Any questions on this so far? Step number 3, find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. In this case here, the third term is positive. So the signs are the same and match the sign of the middle term, which is negative. So the signs are the same and they're both negative. Questions on this here? Okay. Now that brings us to the fourth step, the factors of the first and third term. So we're looking at the factors of 3x squared. Well, x squared's only factors again are what? X and x. That's the only way we can get x squared. And it really doesn't matter what it is. It could have been y squared. Well, then the factors would have just been y and y. Whole lot of questions. But whatever that variable squared, it will match the middle one. We're just going to get that variable twice. Now, the other number with our x squared is 3. What are the factors of 3? Are there any others? So we can just plug it in. Where do we want to put the 3? In the first set of parentheses or second? It doesn't matter. Just pick one. So we can say 3 and 1. So 3x and x. We don't have to write the 1 because it's understood to be there. Factors of 2 are almost
Oh, shoot.
just 1 and 2.
My bad.
Yeah. And again, I'm just plugging them in. Because again, there's only one set of factors of 2, there's only one set of factors of 3, so we're just plugging them in and then we're going to check. (3x times -1 is -3x. -2 times x is -2x. What is -3x minus 2x? -5x. We're really adding two negatives together. Is that the middle term we wanted? No, it is the correct sign, but wrong number. So we need to switch something. Well, I'm going to switch the 1 and 2. You get this here, and we can try it again. This time we have 3x times -2, which is -6x. -1 times x is -x. And what is -6x minus x? Is that the middle term we wanted? So the factors 3x minus 1 times x minus 2 are the factors of the polynomial, this quadratic. Questions on this here? Questions on any of this so far? We're going to stop here and we will pick this up to